This is question 9-1. We're in unit 4 now with our short answer paragraphs. So we have this figure that I've reproduced showing part of a system consisting of a block at the top of an inclined plane that rests on a table, which is located on Earth. The block and plane are at rest when the block is released. In the first case, there's no friction between the block and the plane or between the plane and the table. In trial 2, the plane is fixed to the table so that it can't move. There's labeled trial 1 and trial 2. But there's still no friction between the block and the plane. So the only question is there friction here? Okay, and so in case 1, there is not. In case 2, there is. The question says, indicate whether the speed of the block relative to the table when the block reaches the bottom of the plane is greater in trial 1 or trial 2. And we'll talk about what you need to say in order to get points. So let's talk about what actually happens in each of these cases. In case 1, where there's no friction between the plane and the floor, the block is going to go this way, and the ramp is going to go this way because of conservation of momentum, right? Gravity is going to pull the block down and to the right, which means the ramp is going to scoot off to the left. And that might make you think that the block is going to be going faster, but in that's not actually the case. The answer is case 2, and here's why, all right? So in both cases, this block has the same amount of gravitational potential energy. So whatever that is, say it's 10 joules. So energy has to be conserved. So let's say this is 10, let's just say it's 10 joules. We're not going to put any numbers into this answer. But when we get to the bottom of the ramp, what's going to happen? Well, let's start with the ramp where there's friction, because at the end of this, the ramp is going to have no kinetic energy, and the block is going to have those 10 joules here, okay? If, though, in the first case, the ramp is moving to the left, then the ramp might have, 2 of those 2 joules, which would mean that the block could only have 8 joules. So with more kinetic energy in case 2, the block is going to be going faster in case 2. Another way of saying that is saying that all of the gravitational potential energy is going to be converted into kinetic energy of the block, not and none going into the ramp. So there were 7 points for this question. 1 point for any mention of energy conversion. 1 point for indicating that the same amount of gravitational potential would go into kinetic for each trial. 1 point for saying that the kinetic energy is shared between the block and the ramp in case 1. And 1 point for saying that the kinetic energy only goes into the block in case 2. 1 for describing the motion of the plane in each case. 1 for using conservation of momentum or forces to explain the motion in each trial, and 1 for a coherent argument that leads to the right answer. So 7 points for that one.